When you take a drug, have you ever thought about what really happens to that drug inside your body? Actually, even doctors cannot know that accurately. They always wish if they have something like a small camera that can enter the body and observe what's happening there. Oh, it's like the magic school bus that used to go into a field trip inside the body to observe and treat the problems. Nowadays, doctors hope to have something like that. But is it possible? To do so, we should have a tiny technique that can go inside our body to detect and treat our diseases, as what Miss Frizzle does with her magic bus. Actually, this tiny material is in the nanoscale. But do you know what's meant by nano? As you see in this roller, 1 millimeter contains million nanometers. Materials in nanoscale have different properties than usual in bulk scale. For example, bulk iron oxide has magnetic properties, but nano iron oxide has what's called super paramagnetic properties. Super paramagnetic iron oxide nanoparticles, or spions, our researchers hope to mimic the magic school bus and make what's called theranostic agent. Theranostics is the simultaneous diagnosis and treatment of a disease or disorder. These spions are used as a treating agent by a process called hyperthermia and as a diagnosis agent by magnetic resonance imaging or MRI. Hyperthermia is defined as using nanoparticles in overheating cells above 40 degrees. At this temperature, cancer cells start to die, while healthy cells can tolerate heat up to 45 degrees. Therefore, exposing cancer cells to heat, raising its temperature to 40 to 45 degrees, is enough to make them more sensitive to other treating techniques. On the other hand, MRI is used as a real-time imaging of a treatment process. In this technique, the patient is exposed to magnetic field and radio waves at the region of examination. There are millions of hydrogen atoms that rotates around an axis. When they are exposed to magnetic field, they are aligned in a certain direction, like a compass, and rotate around a new axis. After the magnetic field is removed, the atoms return to spin around their normal axis, releasing some amount of energy. Computers detect that emitted energy and create an image which shows the high dense areas as white and less dense as black. Although this technique provides high spatial resolution images with deep penetration, it has a relatively low sensitivity. Therefore, spions are used as negative contrast agents that can enhance the image quality.